Go, PI, TD, go.
Okay, here's our situation. It's 1:30. The currents are actually leveling off a little bit, but we're still hopeful. So I'd like to proceed with the understanding that we want to launch the rocket at 2 local. I'll give another update if things really level off. Then I'll have to hold. But let's proceed with the understanding that we'll launch at 2. Over.
Copy all PI. And I'm not sure you caught the conversation between myself and RSO over Channel 5. We're at the peak of our wind limit, so we could be red by the time we're ready to pick up the clock.
I didn't catch that.
So they're continuing to do balloons, and she'll report out prior to us picking up the clock.
Okay, I leave that to you, but please understand that we do want to launch.
I got you. We want you to launch, trust me.
Roger that.
Programmer TD.
This is Programmer. Go ahead, TD.
Yes, sir. So we are going to pick up the clock to launch at 1400 local.
Roger. So be 15 minutes in counting at 17:45.
That is correct, sir.
Thank you.
SCO LPM, I'm done with the 400-foot camera, sir.
SCO copies.
And ROA TD.
Go for ROA.
Now let's make sure we got all the items checked off up to the T-minus 15-minute mark.
Yeah, I was just looking at that. RC, ROA.
This is RC, go.
Just wanted to see what our RF avoidance status was. Are we in RF avoidance or are we clear to radiate?
We're still in RF avoidance, but let me verify with radars that they're all down.
LPM, this is ROA.
Go ahead.
Do you need RF avoidance for any reason, or can I release it so we're ready to get rolling?
Yeah, we're done. You can also check items 148, 149, and 150.
Yeah, RC, this is ROA. We're good to release RF avoidance.
ROA and LPM, what about the little GoPro? Is that all set up?
Yes, sir, it is.
Copy, thank you.
RA, RC.
Go for ROA.
RF avoidance has been released.
Thank you. Check 151.
And you can check 154.
ROA, you can check 155. The bypass road has been swept. The launch hazard area is clear.
Copy.
And RSO TD, item 156, the clearance impact area.
Yes, sir. Hazard areas are clear.
Copy, check 156. Check 157.
TD, this is PM.
Go for TD.
Permission to begin the terminal count at 17:45.
Proceed as requested.
Check 158.
Good afternoon, and you're listening to the final countdown steps for the launch of a Black Brant IX sounding rocket from NASA's Wallops Flight Facility in Virginia. It's part of the Dynamo-2 mission. Dynamo stands for Dynamos, Winds, and Electric Fields in the daytime lower ionosphere 2. This mission, we're looking at what they call dynamos, or the electric current in the ionosphere. And so we have two rockets that we're looking to launch as part of this mission. One of them is launching into what scientists are calling a quiet condition, which is today's mission. And then after this launch is finished, we will prepare for the second launch. Will come in the coming days. We have until July 20th to launch that rocket. Today's launch, we're looking at a 2 p.m. launch, which is at the end of the window. There are a couple things that we're looking out for. One is surface winds, which are currently really close to the edge of the limits of where we can launch, so they're continuing to watch that to see if we can go. And also, obviously, the scientist is using ground instrumentation to look at the ionosphere and measuring the dynamo, but he's so far today been pretty positive about being able to launch today. But he did report out here shortly ago that things are starting to calm down a bit. So if things can hold it up together, we're looking good there. The range is also reporting that we're clear as far as ships and boats in the hazard area. So we're hoping today that we'll be able to go for a 2 p.m. launch. Terminal countdown begins in about 8.5 minutes at 1:45 p.m. Today we're launching the Black Brant IX, which is about 61 feet in length. It's carrying a payload about 28 feet long and weighing 1,422 pounds. This is the longest payload that we've flown on this version of the Black Brant IX. This is, again, as Sound Rocket. It's going to be very quick, so if you're in the area trying to watch it, it's going to move fairly fast, so we only have about 40 seconds of viewing time, so be on the lookout. First stage interior motor ignites and then burns out at 5.2 seconds. Those watching video, you'll also see what we have spin motors on the end of the first stage, and they will ignite at 1 second after ignition, and they burn out at 1.6. And those motors are to help spin up the rocket to help give us some stability in the flight of the Black Brant IX, which is an unguided vehicle, which are similar to all the Sound rockets we fly here at Wallops. At the end of the interior burn, it will be an altitude of 0.62 miles and flying at 852 miles an hour. Second stage Black Brant motor ignites 16 seconds after launch, burns out at 43.5 seconds. At that point, it's at 16 miles altitude and flying at 3,818 miles an hour. Apogee today that we're looking for occurs at about 197 seconds into the flight at about 83 miles altitude. At that point, the rocket will be downrange at 90 miles from Wallops. The mission expects to only happen for about 7 minutes on the time up and the time down and splashing in the Atlantic Ocean. And it expected to land in the ocean at about 178 miles downrange from Wallops. Here we're now 5 minutes from picking up today's count for the Black Brant IX sounding rocket. The atmospheric dynamo is a pattern of electrical current swirling in continent-sized circuits high above our heads in the ionosphere, driven by the sun. It migrates across the planet, centered wherever the sun is directly overhead. It comes alive in Earth's ionosphere, a layer of the atmosphere where the sun's intense radiation separates electrons from their atoms, allowing electricity to flow. Most measurements of the dynamo come from magnetometers on the ground, which we have several here at Wallops, and we are monitoring the ionosphere and helping scientists determine when we are going to launch. And these monitor the current disturbances in the magnetic field. Ground-based measurements have their advantage. They can monitor one location for long periods of time, for instance. However, to really get in there and take a look at it, you almost really need sounding rockets, which allows us to fly through into the dynamo to be able to take measurements. In addition, we are coordinating today's launches with the NASA ICON satellite, which is the Ionospheric Connection Explorer. It was launched in October of 2019, flies at an altitude of about 360 miles, and then it looks down on the same ionospheric winds that Dynamo rockets are measuring. The ICON's wind measurements aren't as high resolution as those of the Dynamo rockets. However, they can see a much broader swath of space and can repeat those observations on each orbit. So we're coming up again on just a couple minutes from picking up the count of the Black Brant IX. Launch time today is targeted for 2 p.m., which is the end of the launch window for today. Again, there are two rockets as part of the mission. One is measuring what would they call quiet solar conditions, and that's what we have today, which is a good dynamo according to the project's main scientist, Rob Pfaff from Goddard Space Flight Center. And then the second one will be looking at, I guess, disturbance areas in order for us to fly in the coming days. And we're coming up on just about 1 minute from picking up today's terminal count. Just a reminder for those who are watching in the area of Wallops that there is a little bit of delay from what you're seeing on the screen and what you would see in actual events occurring here at Wallops. So take that into account when looking for the rocket again. We only have about 43.5 seconds worth of rocket burn time, so you need to be watching out. Also, for those looking on the screen, you see that the top of the rocket, the payload section, is wrapped in a box. This is a styrofoam box. You'll see an air conditioning vent that's running up into that area, and so we're pumping cool air into there to help maintain the temperature of the payload system to maintain it around 72 to 75 degrees, somewhere around that area.
$15 minutes and counting.
All stations, Starway on Channel 1. This is NRW 5948 Terrier Mark 12 Black Brant launching from Pad 2 ARC launcher with effective launcher settings of 120.0 as and 77.2 elevation. Please stand by for station checks. All stations should announce status as green or red. RC.
RC green.
M&O.
Green.
SCO.
Surveillance is green.
Programmer.
Programmer green.
LPM.
LPM green.
ACS.
ACS green.
PLC.
PLC green.
PTM.
PTM green.
GSFC.
GSFC green.
UNH.
UNH green.
PI.
PI green.
MM.
MM green.
SRPO.
SRPO green.
PM.
PM green.
RSO.
RSO green.
TD.
Green.
Check 159.
This is final briefing on hold procedures. All stations are responsible for reviewing the go-no-go criteria. Only stations annotated with an asterisk in previous step are permitted to call a hold. All other sites should report red. Check 160.
RSO, Starway.
Go for RSO.
Provide Pad 2 ARC initial wind-weighted settings.
Settings for ARC launcher are azimuth 103.8, elevation 77.1.
Azimuth 103.8, elevation 77.1.
Good readback.
Check 161. LC, this is Starway.
LC, go ahead.
Set ARC launcher to initial wind-weighted settings. Azimuth 103.8, elevation 77.1.
LC copies and work.
PM, DPM, TD, range safety, NASROC, and RCE. This is the Amadon Channel 1.
Go for PM.
Go.
Yes, sir. Just a quick update on Radar 5. It was a tripped circuit breaker. They reset that. They did a system checkout, and the Radar 5 is green and ready to support the count. And with your permission, we're going to go back to the original radar tracking plan. Any questions?
No questions. I concur.
Thank you, sir. PM? Mark, 12 minutes and counting.
M&O, this is PM.
Yes?
Start data recorders.
Stand by. PM, this is the Amadon Channel 1.
PM go. Go for PM.
Stand by.
PLC check 165.
PM, this is the MNO data recorders on.
Check 164. M&O, this is PM.
Go ahead for MNO.
Set ground station levels and confirm, and record signal strength and deviation for all links.
Stand by.
RC, this is
LC.
PM. RC, this is PM.
RC, go.
Interrogate transponder and verify good signal.
It work.
PM, this is the MNO Channel 1.
Go.
Ground levels are confirmed. Links are recorded and confirmed nominal.
Copy. Check 166 and 167.
ROA, LC.
Go for ROA.
Settings for the ARC launcher is azimuth 103.8, elevation 77.1.
Good readback. Check 162.
Check 173.
PLC check 172.
PTM check 171.
ACS check 169, 170.
M&O RC, good luck on the transponder.
Copy. Check 168.
We are on RF best source. PLC, UNH.
PLC check 178. Go ahead, UNH.
Please turn on the main filaments and the motors on the sub and the WIM cooler.
Main filaments on. Motors and the cooler on the sub are on.
PLC, UNH.
Go ahead.
Please turn off the filaments in the main and the motors and the WIM cooler on the sub. Everything is nominal.
Copy. They're off.
Check 179.
ACS check 174, 175, 176, 177.
PLC check 180.
PTM check 181. PTM check 182, tracking 11 satellites.
Seven minutes to launch.
RSO, Starway.
Go for RSO.
Provide final wind-weighted settings.
Settings for ARC launcher are azimuth 103.8, elevation 77.1.
Copy. No change from previous settings.
No change.
LC, this is ROA.
LC, go ahead.
No change to previous settings. Confirm settings. Azimuth 103.8, elevation 77.1.
LC copies. Actual settings for ARC launcher is azimuth 103.8, elevation 77.1.
Good readback. Check 183, check 184.
T-minus 4 minutes and counting for the launch of the Black Brant 9. Coming up at T-minus 3 minutes, we'll start switching the systems on the payload from external to internal power.
PLC, check 185.
M&O, this is PM.
Go ahead, PM.
Record signal strength and deviation for all links.
Stand by.
RC, this is PM.
RC, go ahead.
Interrogate transponder and verify good signal.
Radars still have a good lock.
Copy check 187.
PM, this is the M&O on channel 1.
2 minutes.
PM go.
Links recorded and confirmed nominal.
Copy check 186.
ACS check 188, 189.
UNH check 191.
PLC, check 190.
PTM, check 192.
PLC, check 193.
ACS check 195, 196.
ACS check 197.
PTM, check 198. Pressure 76.4 psi. Check 199. Check 200.
T-minus 1 minute.
Please confirm go status. PLC.
Go.
PTM.
Go.
ACS.
Go.
PI.
Go.
SRPS.
Go.
MMs go. Check 202.
Carrier arm, Mark 203.
ACS check 204. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, launch.
First stage burnout.
Radars 5 and 18 are tracking the payload.
Second stage ignition.
Radar 3 is tracking the booster.
TM tracking up the pad.
Second stage burnout.
Radar 3 successful tracking of booster switching to payload.
Motor set. Main skirt set. Event relays on.
Radar 3 is
Caps
tracking
deploy.
payload. 3, 5,
IG
and
filaments
18
on.
is tracking
Nose cone
payload.
deploy. Motors on. Coolers on. IG filaments on sub. Booms deploy. CT IT filaments on. Sphere has deployed.
Still good TM lock on all sources.
High voltage on. Payloads at Aperture per GPS, 123.5 kilometers.
TD, this is LPF.
Go for TD.
Yes, sir. Can we get some folks out to the pad to take a look for gross hazards real quick?
If GSO is good with it, I'm good with it.
RSO, this is LPM.
Go for RSO.
Yes, ma'am. We clear to get a crew out to the pad to take a look for gross hazard?
You're clear.
Copy that.
Altitude 90 kilometers per GPS.
RSO, this is LPM on channel 1.
Go for RSO.
Yes, ma'am. Can we release our LHA roadblocks? We still have our PLDA roadblocks in effect.
Yes, sir.
Copy that.
LOS 9 meter.
Now you heard we have loss of signal, which completes today's mission. The payload flew to
we had a good
approximately
event,
76,
and
70.
we're just thrilled we had a good launch. So thanks to everyone for all the support.
Thank you, sir.
So it sounds like the principal investigator was happy with today's mission. A good mission, good data. We've report loss of signal so that the vehicle has impacted into the ocean. So launch time today was at 2 p.m. We flew to an apogee of 76 miles, a little bit lower than predicted, but still good for the science to be obtained. And for our next launch of the Black Brant IX, it's no earlier than tomorrow, but we do need to prep the vehicle and get it ready for flight. So for updates, follow the Wallops Twitter and Facebook feeds for that. And then we're also watching, of course, tropical storm or hurricane storm, whatever it is now, Elsa, as it's coming up the coast, which may have an impact on our launch opportunities for the next 2 days. So we'll also be looking at that. So again, watch the Facebook and Twitter sites for our next launch opportunity. And thanks for joining us.